In this video, we're going to demystify the Alembic package in Python. Alembic is a database migration package that's commonly used in Flask and FastAPI applications, as well as with any other framework that requires a migration model that's not built in, such as Django's. And when you're working with databases, migrations are a very important tool to maintain consistency and allow you to roll back changes. In this video, we're going to create a Postgres database and build up a small schema using Alembic and SQLAlchemy. And we're going to show the basic operations that you can do in Alembic and how to apply changes to your database with this migration package. So let's get started. So let's start with a quick look at the Alembic documentation, which I'll leave a link to below the video. Alembic is a lightweight database migration tool for use with SQLAlchemy. And we're going to look into some of the topics here later in the video, such as creating a migration environment. And we'll also look at auto-generating migrations from SQLAlchemy models that are defined in our applications. Now, what we need to do to get started is actually have a database where we can then apply migrations to. So we're going to use PostgreSQL. And to keep things simple, I'm going to use a Docker image that I'm going to get from Docker Hub here. So I'll leave a link to this below the video and you can copy the command on the right here, docker pull postgres, and we can go to VS Code. Now I have an empty directory open here. We can paste into the terminal the docker pull command, and then that's going to bring the PostgreSQL database image down onto your computer. And this will also work if you're not using Docker. If you want to download Postgres directly, I'll leave a link in the video for that as well. Now, once we've downloaded Postgres, you should see the image when you run the command docker images. So I'm going to run that just now, and you can see we have a couple of Postgres images at the top here. Now, what you can do in Docker is start a container from the image. And in order to do that, let's go back to the documentation for this Docker image for PostgreSQL. And if we go down here, we have a docker run command. Now, I'm going to use a modified version of this command in order to start a container that's running PostgreSQL, and then we can apply the migrations to that database. So let's go back to VS Code. I'm going to clear the terminal, and what we're going to do is we're going to issue a docker run command, and we're going to give the container that we're about to start a name of Alembic-demo. Now we need to be able to connect to the database running in the container, so we're going to map port 5432 in the container to 5432 in the host with the -p flag to this docker run command. And once we've done that, we're going to set an environment variable called Postgres password, and we're going to set that equal to secret. And in production, that can come from somewhere more secure, such as a .env file. And what we can also do is we can pass the -d flag to the docker run command, and that's going to basically run the container in the background. And that will free up the terminal that we have in VS Code so that we can run the Alembic commands later in the video. And the final thing to pass is the actual image that we want to start the container from, and that's the Postgres image that we have just pulled. So let's now run this command, and you can see we get the container ID that's been started here, and we get the control of the terminal coming back here because we've started that in the background with the -d flag. Now we can verify that Postgres is now running. There's an actual container running with the docker ps command. We get back the container ID for that Postgres container, and you can see the name of the container that's been started, and that's Alembic-demo. So the PostgreSQL database server is now running in Docker. We can now create an actual database within that server. So what we're going to do in order to do that is we're going to run a docker exec command, and the name, or rather the name of the container that we're going to connect to is Alembic-demo, and the command we're going to run in that container is the create db command. So we're going to create a database. The user is Postgres, and let's call the database Alembic_db. So we now have that database, and that's the database we're going to connect to from Alembic. And we're going to make changes to that database, add tables and add different columns to tables using Alembic migrations. So let's get started with that now. Now what we're going to do to start with is create the migration environment. But in order to do that, we need to actually install Alembic, and we're also going to install the 𝗖𝗵𝗽𝗁 package, which is the PostgreSQL driver for Python. So you might notice on the left hand side here, we have a virtual environment. I'm going to activate that environment now, and we're going to run the pip install commands. So once the environment is activated, you can run pip install Alembic and 𝗖𝗵𝗽𝗁2. Once those are installed, we can minimize the terminal a little bit, and what we're going to do is go back to the documentation, and we're going to look at the migration environment that comes with Alembic. So when you use Alembic, you start by creating the migration environment. And this is a directory of scripts that is specific to a particular application. And the migration environment is created just once and is then maintained along with the application source code itself. So the migration environment is going to be committed to your repositories on GitHub or GitLab or other systems like that. And in order to actually create the migration environment, you use the Alembic init command. Now there's some structure here for the resulting environment, but what we're going to do is we're going to go back to VS Code and we're going to run the Alembic init command, and we need to give the environment a name. So I'm just going to call it my app. Now when we run that, you can see what's been created on the left hand side. We have an alembic.ini file, and this is the file that Alembic scripts look for when you invoke the Alembic commands. And we'll see a little bit more about what this directory does later in the video. If we look at the my app directory, what you can see in here is that we have a directory called versions, which is currently empty. And we have an 𝗵.py file here as well. And 𝗵.py is a Python script that is run anytime the Alembic migrations are invoked. And if you look at this file, you can see a couple of things being imported from SQLAlchemy. And this file will always be run when you perform your migrations, and what it's going to do is it's going to use SQLAlchemy and use the engine that's provided by SQLAlchemy in order to connect to the database. And it uses this engine from config function from SQLAlchemy. If we go down to line 60 here, in the run migrations online function, we create a connectable variable here by running the engine from config function. And then we have a couple of context managers here to connect to the database and then to start a transaction that's going to run the migrations. Now we don't need to know too much about this 𝗵.py file. What we're going to do now is we're going to tell Alembic how to connect to our database that's currently running in the Docker container. Now in order to do that, we're actually going to go to the alembic.ini file. And in this file, we're going to edit one setting, that's a SQLAlchemy.url setting. So you can see at the moment that we have this generic code here. We need the driver, which will be a Postgres driver or a MySQL driver or one of the other databases. We also need a user and a password and a host, and then the name of the database that we're actually connecting to. So I'm going to paste in some code here. So let's remove this. And what we're going to paste in here is this line of code. We have the driver, which is PostgreSQL. Our user in that database was the Postgres user, and the password here was secret, not my secret password. And that was specified in the docker run command when we passed that Postgres password environment variable. And then we have the host, and we're going to use localhost here, and the name of the database that we created was AlembicDB. So this line of configuration here will tell Alembic how to connect to the database. That is the connection URL that we're going to use. So now let's get started by running some migrations. Now in order to create a migration, we have a command called Alembic revision that we can invoke, and we can pass a message to that. And that's similar to the message you use on GitHub, for example, when you make a commit. The message just describes the migration that we're about to create. So let's just say we're about to create a user table in the database. We can create a revision with that message and then execute this command. And you can see what has happened on the left hand side. Under the versions directory, we now have this revision that's been created here with the name. It's got a hash here, and then create user table, which matches the message that we used. So if we open that up, let's see what is in that file. So this is an auto-generated file. It's got a revision ID, and if we scroll down, you can see we have the revision in a variable here. We have another variable under that called down revision, which is currently set to none. And this will be none only on the first revision that you actually create, the first migration. And the purpose of this variable is to point to the ID of the previous revision in our Alembic configuration. We'll see a bit more about that in a second. And we have two empty functions here, one called upgrade and the other called downgrade. Now in Alembic, what we can do is we can add code to define what happens in the migration to the upgrade function. And the downgrade function, we can add code in here too. And the code we add here tells Alembic how to reverse the migration. And later on, we'll see how to auto-generate the code that is added to these functions from SQLAlchemy models. But for now, let's define the code here, and we're going to use some Alembic directives in these functions in order to define what happens for the revision. Now, if we go to the top here, you can see from Alembic we've imported op, and this can be used to define the operations in the database for this particular revision. So we're going to use the op.createTable function. And the first parameter to create table is the name of the table. And even though we called the migration create user table, I'm actually going to create a table called employee here. And we're going to define some columns now for that. You can see on the VS Code highlighting here, we can define any number of columns after the table name here. Now we have access to SQLAlchemy columns through this SA object, so we've imported SQLAlchemy as SA. So let's go back down to the upgrade function and we can define columns using SQLAlchemy.column. So let's define the first column, and that's the ID column, which is going to be the primary key for the table, and that's going to have a data type of SQLAlchemy.integer, and we can pass primary key equals true to that table. Once we have that, we can define the second column, so it's going to be SA.column, and the name of the column is going to be name. This is going to be the name of the employee, and that's going to be a data type of SQLAlchemy.string with a length of 50, and we want to make sure that that is not nullable, so we're going to pass nullable equals false. Every employee must have a name. And let's now define the final column using the SQLAlchemy.column, and the name of this column, let's just call it current, and this is going to check whether or not the employee is currently employed, and that could potentially not be the case if we have a table of employees, but some of those employees are no longer employed, they've been sacked or they've moved on. So this is going to be a Boolean column that tracks that, so it's going to have the data type of SQLAlchemy.boolean, and let's default that value to true. So that is the upgrade function that defines an operation that creates a new table for this particular revision, and we need to also define, or we can optionally define, the downgrade function as well. So all we need to do in downgrade is basically reverse the migration. So let's use the op.drop table function, and the name of the table we're going to drop is the employee table, and that will essentially reverse the operation that we have in the upgrade function, and it's going to remove that employee table from the database when we downgrade or when we reverse the migration. So let's save this revision file, and what we're going to do now is we're actually going to run the migration against the database. Now in order to do that, we have a command in Alembic, and that's the Alembic upgrades command, and to that we can pass the revision ID of the particular revision that we want to apply here. But most conveniently, if we just want to apply the most recent migration, we can use the Alembic upgrade head command. So let's run this command now. And you can see it's applied some kind of upgrade here, and it's got the revision ID for this file that we have. And again, the message I put create user table, it should have been create employee table. But the important thing to check is, has this table been created in our PostgreSQL database? Now in order to check that, what we're going to do is connect to that database using the docker exec command, and we're going to pass the name of the container we want to connect to, and that's the Alembic demo container, and we're going to connect using the Postgres command line tool, and that's PSQL, and we need to pass a user to that, which is the Postgres user, and the database with the -d flag that we're going to connect to is the Alembic DB. So let's run this command, and now you can see we're connected to the Postgres database. We can run the /dt command in the PSQL tool, and that will display the databases or the relations that we have in the Postgres database, and you can see we do have a table now called employee. Now we can issue a select command, select all from employee, and that currently returns no rows, but you can see the structure of the columns. We have an ID column, a name column, and a current column, and that matches what we passed into the Alembic op.create table statement. We had 3 columns here with the exact same names, and you'll find that the data types for these columns and everything else is as we defined them in that operation. Now let's say we wanted to perform a further change to this table. We have ID, name and current, but we might want to also add a job title for each employee. So the process of changing the database again, or changing this particular table, is that we create a new revision with the Alembic revision command, and we can pass a message to that as before, and the message we're going to pass is add job title column. Now actually I need to get out of the PSQL tool, so what we can do is stop that, and the /q command will get us out of PSQL, and then we can paste that back into the terminal. So we need to do this on our local computer, not in PSQL on the container. When we do that, you can see that we generate a new revision file on the left hand side. So the versions directory here, every time we create a revision, it's put into that directory. And if we look at this file, you can see some details that we have here. We have the revision ID as before, but this time we have a down revision with an ID that points to the previous revision file. So every time we create a new revision, it's going to point to the previous one, and this allows Alembic to build up the correct order of the revisions when it performs its actions against the database. So these IDs are very important. They allow Alembic to understand what was the first revision that was created. That one has a down revision of none. And from there, it can look at all of the files and look at the down revision and build the correct historical order for these revisions. And that's kind of similar in programming to a linked list, where you have a pointer that points from one item to the next item, and then from the next item to the one after that. So what we want to do in this revision is add a new column to an existing table. So what we're going to do in the upgrade function here is we're going to use the op.addColumn directive. Now remember, when we created the table, we used the create table directive. This time it's going to be add column, and again the table name needs to be the first parameter here, and this is going to be a new column in the employee table. And what we're going to do to define the column again is we're going to use the SQLAlchemy.column, and we're going to pass the name of our new column, which is going to be job title. And a job title is going to have a data type of string, so let's pass SQLAlchemy.string, and we'll give it a length of 64. And finally, we'll allow this one to be nullable, so we can set nullable equals true. And let's also define the code for the downgrade function. So in order to reverse this, we can use the op.dropColumn function. So drop_column, and the name of the table that we want to apply this to is the employee table, and the column name that we actually want to drop is the job title column. So let's now save this. This is the code that defines our revision. What we can do once we've saved that is go back to the terminal, and we can run Alembic upgrade head. And this time it's running the upgrade from our previous ID to the new one, and it's adding that job title of column. So let's go back to PSQL using the docker exec command that we ran before, and if we run select all from employee, we can see this time we have a new column in that table called job title. So that's working fine. We're applying these revisions, and we're able to change the structure and the schema of our underlying database using Alembic. Let's get out of the PSQL console, and we can also show a couple of extra commands here. We can run the Alembic history command in order to generate the history from the first revision up to the most recent revision. And this is from the most recent one, which is at the top, to the very first revision, which is at the bottom. If we run that command, we can see the historical revisions that have been applied with Alembic. Let's now talk about downgrading the database. What you can do with Alembic is you can download to the last version, or you can optionally entirely roll back all of the changes that have been applied to the database. So for example, if you wanted to downgrade to the last revision, and that's the one before we added the job title column, we can apply what's called a relative migration. And relative migrations, they operate in place from the current revision. So I can run a command here called Alembic current, and that gives us the ID of the current revision that we have, and it's the one beginning with C here after we added the job title column with this function here. So a relative identifier will work relatively from the current migration. So in order to downgrade, what we can do is we can run a command called Alembic downgrade, and we can add a relative identifier here, and that's just a number. So let's add -1, and what that's going to do is it's going to downgrade to the previous revision that we have from the current revision that we're on. So let's run this command, and you can see we get this output here. If we go back to the PSQL terminal here and we rerun the selection, you can see we no longer have the job title column. So what's happened when we run the Alembic downgrade command is that we're telling Alembic to revert the last migration. Now let's rerun the Alembic current command, and you can see that the current migration that we're on, it's no longer the one beginning with C, it's the original migration where we actually just created the table. So Alembic now knows that this particular migration beginning with C is no longer actually applied in the database. We can again apply a relative migration here with the Alembic upgrade command, and instead of passing head to that or passing a revision ID, we can actually pass a relative identifier here. So if we pass +1, what it's going to do is it's going to apply the next migration from wherever we are currently. So let's run that, and it's going to re-add the job title column. Again, if we go back to PSQL here and we show the selection, you can see we now have the job title column. So this is important. We can apply relative upgrades here, relative downgrades, from wherever we currently are in the tree that represents our migrations. And if we want to completely revert the entire history of migrations, we can run Alembic downgrade, and we can pass base as the identifier here. That's going to completely reverse everything and go back to the original state of the database. Let's go back to PSQL on Docker, and again, if we select all from employee, this time we get back the statement that the relation employee does not exist. That's because the table is no longer in the database, because we've reversed the entire history of the migrations. So let's regenerate everything with the Alembic upgrade head command, and that's going to apply all of the revisions and regenerate that employee table with all of the columns. Now let's finish this video on Alembic by looking at how we can auto-generate migrations from SQLAlchemy models. Now if you use something like Django, you know that when you change a Django model, you run the make migrations command, and Django automatically detects what's changed, and then when you run the migrate command, it will apply those changes and change the underlying database. So how do we do something similar with SQLAlchemy? This is useful because we don't want to always specify the code ourselves when we have an upgrade function. If we change a SQLAlchemy model class, it would be very useful if the changes that we've applied to that model are automatically picked up by Alembic, and those changes are applied to the underlying table when we actually run these commands without us actually specifying the code ourselves. Now let's start by removing all of the changes that we made to this database. We can do that with the Alembic downgrade base command that we saw a second ago. And then what I'm going to do is actually remove these two revision files entirely. So let's delete these from the file system, and we can remove them from the PyCache as well. So we're back to our original state with an empty versions directory. What we're going to do now is at the top level of this directory structure, we're going to create a models.py file alongside the alembic.ini file. And let me make the terminal smaller here. At the top, we're going to bring some imports in from SQLAlchemy, and that's the column, datetime, string, integer, and func objects from SQLAlchemy. And we're also going to bring in the declarative base. So let's create an object called base here by instantiating declarative base. And we can create some metadata from that. So metadata is going to be equal to base.metadata. Now we can create subclasses of this declarative base. So let's do that just now. We're going to create a class, and let's just call this one company, and that's going to inherit from that base class. And the base class, you can think of it as kind of similar to the Django model class if you're familiar with that. And we can also have a double underscore table name property, and that tells SQLAlchemy what we want this table to be called. So let's call it company. Now a SQLAlchemy model, just like a Django model, it consists of columns. So we're going to create a column called ID, and that is going to be a data type of integer. And remember, we imported these at the top, and we can pass primary key equals true into the ID column. Let's now create another column called name. So again, it's a column. This time it's going to be a data type of string, and we'll give it a length of 60. And for the name of the company, let's add another constraint here. We're going to say unique equals true. And one more column, let's add one called createdAt, and that's going to be a column of type datetime. And we're going to give this column a default value of the func.now function in the underlying database. And finally, in this model, let's define a downgrade method, and that's going to print the ID of the company as well as the name of the company. So this is a model. We now need to tell Alembic about this model. So where can we actually do this? If we open up the My App Alembic migration environment, we can actually edit this env.py file. So I'm going to go to the top of this file, and we're going to bring some imports in here for our model. But what we're going to do first is go to the documentation in Alembic for auto-generating migrations. I'll leave a link to this below the video. What it says here is that Alembic can view the status of the database and compare against the table metadata in the application and generate the obvious migrations based on the comparison. And this is achieved using the --autogenerate option in the Alembic revision command. What this is going to do is it's going to place the so-called candidate migrations into the new migrations file that's created in that versions directory. And as a developer, you can then review and modify those by hand and then proceed normally with the Alembic upgrade. Now to use autogenerate, you need to modify that env.py file, as I said, so that it gets access to a table metadata object that contains the target. What we need to do basically is defined in this code here. we need to import the declarative base class and then reference the target metadata and set that equal to that base.metadata property. So let's do that in 𝗵𝗽𝗀 now. At the top, underneath the Alembic import, from the models module, let's import the base class. And then we can find the declaration of target metadata, and you can see that's down here on line 22. And what we can do is change that from none, and we're going to reference base.metadata. So now that we've linked the metadata here containing the table objects to Alembic, we can now pass that --autogenerate flag to the Alembic revision command. So let's try that out now on the terminal. I'm going to clear the terminal and we're going to run the Alembic revision command, and this time we're passing --autogenerate. Now, as well as that, we need to again pass a message in for this, and let's pass the message added company model. Let's run that now and see what kind of output we get. If we look at the revision file that's created in the versions directory, we can see what SQLAlchemy, or rather what Alembic has added to the upgrade function based on this SQLAlchemy model. We have another op.create table directive. We create a table called company, and you can see there are columns for the ID, the name, and the date time for created at. So it's got those completely correct, and we also have a primary key constraint on the ID field and a unique constraint on the name field. So that looks completely fine. If you look at the downgrade function, you can see it simply drops the table company, and that is totally fine as well. That is the reverse of that migration. We just get rid of the table that we're creating for that model. So you can always modify these if you need to, but if you're happy with that, what you can do on the terminal is run the upgrade. So it's the Alembic upgrade command, and we can pass head in, and we get back the statement that says we've added that company model. I'm going to go back to the Docker PSQL tool, and what we're going to do in here is display the tables, and you can see we now have a company table in the database. And again, this is going to work perfectly fine. If we go back to models.py and let's create a new column in this table. So we're going to create a column called address. So that's going to be a SQLAlchemy column. Let's just make it a string for simplicity, and we'll set nullable equal to true here. If we go back to the terminal, we can clear that, get out of the PSQL tool, and again we're going to run Alembic revision --autogenerate, and this time we have added address to the company model. So let's run this command to create the revision file, and again we can go back to that revision file and we can inspect what's been added to that file. So if we go to the upgrade command here, the upgrade function, you can see we have an add column statement for a column called address. And the downgrade function will simply remove that column from the company table. So that looks good as well. What we can do is go back to the terminal, and I'm going to run the Alembic upgrade head command again. And this time let's go back to PSQL, and we're going to select all from that company table. So select all from company. When we run that, you can see we now have the new address column in that table. And that's going to be about all for this video. We've showed how to create revisions in Alembic. We've shown how to set up the alembic.ini file in order to connect to a database. And we've seen how to define operations in the upgrade and downgrade functions that come in your revision files. And we also saw how to integrate Alembic with a SQLAlchemy model class in order to auto-detect changes that have been made to SQLAlchemy models and apply those in your revisions. Now there's so much more that we can do with Alembic. If you're interested in more content, let me know in the comments. And we will also use Alembic in upcoming videos on FastAPI when it comes to integrating FastAPI with a relational database. But for now, thank you for watching this video. I hope you've enjoyed the video and learned something. If you have, please give it a thumbs up and subscribe to the channel, and we'll see you in the next video.